All right, we're going to look at solving systems of equations. We've already talked about two ways of solving them. First way is by graphing. So you could graph the two equations. Let's say they were both lines, and you could determine the point of intersection, whatever those coordinates are, and that would be your solution to your system of equations. The second way is to use substitution to solve a system. You get one letter by itself, substitute that expression in the second equation, and then solve that equation for the remaining variable. Once you have one of your coordinates, then you can plug it back in and find the other coordinate. So here we're going to look at the addition method. It's also called the elimination method. We'll see in a second why it uses. You hear either of those phrases, both apply. And this is another way to solve systems of equations. And we'll look at what if I have two variables, and then what if I have three variables, how I can do this. And again, I'm going to stick with linear equations, but this would apply to nonlinear equations as well. Just realize in order to add two things, they have to be like terms. So if that's not the case, you couldn't do it using this technique. So let's say I had a system of equations that was, I wanted to solve this. 3x plus 2y equals 10, and 2x plus 5y equals 3. Okay. Now I could do this substitution. I could solve for this first x, which means I'd have to divide by 3 fractions. I'd have to solve for this y. I'd have to divide by 2 fractions. This second x, divide by 2 fractions, or I could solve for this y, and I'd have to divide by 5, so fractions. So there's no great choices here. I mean, some are better than others. I'd probably either go with this y or that x. I'd rather work in halves than thirds or fifths, but there's not a great choice. So what I want to do here is, and I'm going to go through these steps. There's like a 0 step here is line up the terms. Line up the terms. So if this is not, notice my x's are in line with each other, my y's are in line with each other, and my constants are in line with each other. If that's not the case, move things around so that is lined up. Second thing we want to do is we're going to multiply each equation so that the coefficients of a variable are opposites. Same magnitude, different sign, right? So I need to decide if it's going to be easier to match up my x's or easier to match up my y's. In this case, neither one's really hard, but I'm just going to decide which to match up. So I'm going to match up my x's in this case. You don't always have to do that. It's just my choice. So I'm going to ask myself, what's the least common multiple between 3 and 2? And that would be 6. So I'm going to multiply this top equation by a 2 and multiply this bottom equation by a negative 3. Okay, I'm going to distribute that through. So that's going to give me 6x plus 4y equals 20. That's the top equation, everybody multiplied by 2. And then the bottom equation becomes negative 6x, negative 15y equals negative 9. And so I multiplied everyone in the second equation by negative 3. And now what I'm going to do is I'm going to add these equations vertically. So 6x added to a negative 6x, those cancel out, they're gone. And then 4y and a negative 15y gives me a negative 11y. 20 minus 9, that's 11. And notice in this process I have added these equations, hence why you might hear this called the addition method. And I've also eliminated one of my letters, why you might call it the elimination method. So like I said, either phrase applies, and you might, one textbook might use one phrase and a different textbook might use a different one. And so now what I want to do is solve. So I'm going to divide both sides by negative 11, and get y to be -1, back substitute for the other variable. Right? So now that I know what y is, I can go to any equation that has y and an x. So I'm just going to pick this first equation. 3x plus 2. We now know y is -1 equals 10. So that's 3x minus 2 equals 10. Add 2. 3x equals 12. Divide by 3. X equals 4. And remember to write your answer as a point. We're looking for that point of intersection. So 4, -1. So that's the general idea. You can have some special cases. So let me real quick mention those before we move on to the 3 variables. So, and I'm just going to just match these up. So let's say I have 2x minus 3y equals 5. And -2x plus 3y equals 1. Let's say this matched up this way. Added these together, I got 0 equals 6. Well, 0 cannot equal 6. So this means the system is inconsistent. Let's say instead you had 4x plus 6y equals 8. And -4x and -6y equals -8. Well, 0 equals 0. Well, that's always true. We say the system is dependent. These lines are the same line, is what that's telling you. If you get 0 equals 0. So those are special cases that can happen. If you, on this one, you want to find out what the format of the answers are, what you would do is you would usually solve this equation for y, so divide everybody by 6. So y equals -2/3 x plus 4/3. And you'd say the answer is x could be x and y could be 2/3 x plus 4/3. So in other words, the value of y is dependent upon the value of x, if you needed to go that far. Otherwise, you could just say dependent based on what course you're taking. All right, so let's say I have 3 variables, and I want to solve that. So let's say I have solve 3x. When you're doing these, make sure you're very careful about writing the problem down correctly. If you write the problem down incorrectly, it doesn't matter how good you are, things aren't going to work out right. So be careful. A lot of times these problems are all kind of crammed in. Let me just double check my numbers here. Okay, looks good. All right, so what I'm going to do, my goal here, is to go from 3 equations that involve 3 variables down to 2 equations that involve 2 variables, and finally down to 1 equation with 1 variable. That's my goal. And the way I'm going to achieve that goal is I'm going to add 2 of these equations together and get rid of one of the letters. And then I'm going to add a different pair together and get rid of the same letter. So you think about the ways to match these up. Let's say I would call this equation A, B, and C. So you can add A to B, that's one pair. You can add A to C, that's another pair. Or you could add B to C, that's a third pair. The important thing is you eventually work with everybody. And so I need to just decide which letter do I think is going to be the easiest to get rid of overall. No great choices here, so I'm just going to go with X. And so what I'm going to do is I'm going to do A plus B, and then I'll just do, I don't know, A and C. Okay? So Notice if I just add a and b together, that's not going to get rid of the x. So I'm going to have to change the signs of one of them. So I'm going to leave a as a, and I'm going to do the opposite of b. So a, 3x plus 3y, so 5z equals 1, and then the opposite of b, so negative 3x, negative 5y, negative 9z, and 0. Negative 0 is still 0. So my x's cancel out. Negative 2y, negative 4z equals 1. And I'm going to call this little a, because it's smaller than big A. And notice I have an equation with y's and z's. So what I need to do is come back up to these three, pair up a different pair, and get rid of the same letter I just got rid of. Get rid of x. And so like I said, I'm going to do a and c to do that. So looking at x, 3 and 5, the least common multiple is 15. So I'm going to do 5 times a, and that'll give me a positive 15. And I'm going to do negative 3 times c, and that'll give me a negative 15. And positive 15 and negative 15 will cancel out. So top equation by 5, 15x, 15y, 25z equals 5. Make sure you multiply everybody by that number. Then we'll multiply everybody on the bottom line by negative 3. So negative 15x, negative 27y, negative 30, negative 51z, and 0. And I'm going to add those together. Again, the x's cancel out. I have, what, negative 12y, negative 26z equals 5. And I'm going to call that little b. So now, with little a and little b, I now have two equations with two variables. Notice if I'd gotten rid of a different letter, then I might still have, like, let's say an x and a z, then I would actually be working with 3 letters. So what I want to do is I want to eliminate how many letters I'm working with at any given time. So y and z, y and z. Need to put these together and get rid of something. So I think it'll probably be easier to match up the y's. So let's put b together with negative 6 little a. Negative 6 times negative 2 will make it out a positive 12, which will cancel out that negative 12. So negative 6 times everybody in little a. So positive 12y, positive 24z, and negative 6. So let's cancel out. Negative 2z equals negative 1. Divide by negative 2. And z equals 1/2. Alright, so now that I know what z is, I can figure out the rest. I want to take this answer and take it somewhere where it has z in one other letter. So how about little a over here? So I'm going to substitute in my negative 1/2 for my z value. So negative 2y, negative times negative, positive half of 4 is 2, equals 1. Subtract 2. So negative 2y equals, that's strange. Hold on. Oh, no, sorry, this is a positive half. I knew something wasn't looking right. So, yeah. So this should be negative 2. It's positive, positive. Okay. All right. Negative 2, negative 2. So y equals negative 3/2. Now that I know z and y, I want to go somewhere where it has an x as well. So let's say I go to capital B here. Capital B. 3x plus 5 times negative 3/2 plus 9 times positive 1/2 equals 0. So 3x, this is going to be what? Negative 15 halves, positive 9 halves. That'll be negative 6 divided by 2 is negative 3. Add 3. 3x equals 3, divide by 3. x is 1, y we said was -3/2, and z is +1/2. And there's my order triple, three-dimensional point, length, width, height. So that's the general idea for doing 3 equations. You add 2 pairs up, you cancel out a letter, then put those 2 together and get rid of a letter, and then solve. Once you know one of the values, you can start plugging them back in, working it out, and then plug both of those back in and get a final answer. So now I should note, if you're missing a letter, like let's say this C equation didn't have an x, just had 9y and 17z, I could just grab that and take it to step 2. My 2 equations, 2 variables. If it already had just 2 letters, then it's ready to go for the second step. I just have to make sure I put the other equations together and get rid of the same letter this one might be missing. So now, since all of them had that didn't work out this case, and this is pretty standard what you'd see, but those can kind of save you some times if you notice some equations are missing a letter. Anyway, solving system of equations by the addition.